Okay, one of the things that we've been talking about are Newton's laws and forces. And a very important force having to do with energy is the force of friction. Friction is unavoidable. It's one of the reasons why you can't ever have a perpetual motion machine. It's why we always are losing a little bit of energy to what's called thermal energy. So even though the total energy in a system is always conserved, it can be converted from one form to another, and frequently some energy is converted to thermal energy because the force of friction acts on the objects that are in that system. So what we've got here is just a very simple system with a ramp and a block, and the block has four different materials on it on each side that have different roughnesses. And because of those different roughnesses, they have different coefficients of friction, which just means that the frictional force acting on them is different. So if I put this sandpaper side on the ramp and I set the block on the ramp and give it a shove, it comes to a stop. So when I gave it a shove, the block had kinetic energy for a second. It had energy of motion. Now it has stopped. Where has that energy gone? The force of friction did work on the block over the distance that it took for the block to come to a stop, and that work equals the amount of energy that was converted from kinetic energy into thermal energy. So the energy wasn't destroyed, but it has now become something that we can't make use of. Very slight temperature increase in the surface of the ramp, and a very slight temperature increase in the surface of the block here. Now, if I increased the angle of this ramp significantly, then let it go. Friction is not able to stop it. I'm getting gravitational potential energy for the block being up high, converted into kinetic energy, and we have a conversion from gravitational potential energy to kinetic energy, and this thing speeds up until it hits the bottom. But if we go back down to our lower level here, just to show that the frictional force depends on the particular objects that we're working with. Again, with the sandpaper, it comes to a stop. If I now put it on this smooth Teflon face, which has a much lower, what's called coefficient of friction, and set it here, the block slides easily. So the force of friction acting from the ramp on the block depends on what the materials are. And in the case of a slippery material, that force of friction is not enough to stop the gravitational potential energy from being converted into kinetic energy and allowing the block to slide down. If it's on sandpaper, then I can push it over and over and over again, and each time I do, I'm exerting a little bit of force on the block. I'm putting some energy into it. The force of friction acts against that kinetic energy and converts it back into thermal energy.